Hello everybody, this is Charles Anderson, and I'm just a guy from Goodwell, Oklahoma, and I've got a really great video game idea. This is part 10 classes in my JMonkey Engine Java Basic series. I've got an email address for anybody that wants to give me a holler. But yeah, this is actually a retake, and it's kind of hard for me to mentally keep focused on this one because classes, methods, inheritance. Once you jump into object-oriented programming, it's easier to just code and have fun with it and learn the limitations. I'm doing this presentation for those people who are jumping into Java. I'm going to run through it straight and then I'm going to play with it. But I'm running straight through it for those people who are just needing to adapt their thinking over to Java, from some other language. However, I am jumping into playing with it for those people who, may not have this whole thing down. Who are touching this for the first time. So yeah, classes just come from packages, and the big thing about Java is classes. Object-oriented programming. Hey, let's reuse it. All that good stuff. The keyword class in Java refers to this data object. Okay, and it can contain primitives. The numbers, the characters, the words, all that good stuff. The data values. Methods. Hey. What the code that actually it does stuff. All right, and because it's object oriented and a class is a kind of a data object that gets resolved into a reference value primitive. It can contain other classes within itself. So yeah, you can fold it up however complexly you want to, but it's usually best to keep it simple. It's natural value. It's primitive. Yeah. Is that of a reference type variable. So yeah, even though all this code and values and stuff, an instance of it gets put onto the heap for an instance, or into the static if there's just one copy of it needed. That reference value. When you refer to this class, it's actually giving a number of its location in memory. Keywords, yes, and I'll be hitting those keywords up next. These can help define the nature of the class being created. And of course, I'll start by hitting it from the package level and then go on into inside of a class. There's actually a little bit of difference because of the way that we should kind of think of classes in Java. So a class, and this is the big point, and this is for all object-oriented programming that I've seen. A class, all right, you can use it when you have it completely nailed down and defined. By nailing it down, I mean you have it actually put into the static side or the heap side of memory, and it's created and initialized, and then you can start playing with it in your methods. So boom, or main as the program is from where we're at. So once it's nailed down and defined, boom, you can use it. The only reason I mention this is because there is abstract. There is the implements keyword and other stuff where you've got this preset structure in mind, and you've defined that preset structure, and you still have to write the code for it. So hey, there you go. All right. Classes and methods. Classes and methods, they share a lot of the same keywords. But there's a big thing. Classes are meant for the heap, or the static part of the heap, and methods are meant for the stack. So yeah, go figure, because classes are data and methods are actually working with it. So primitives, methods, and classes declared in a class exist until its instance is disposed of off of the heap, or public static void main exits, which is out of the stack. But it's the biggest part of the stack because it is your program. Go figure. And now, primitives, methods, and classes declared in a method exist until the current method exits. So, yeah, public static void main, yeah, that's actually a method. So, yeah, all the stuff that's declared in a method, yeah, it exists until the current method exits. So, when you exit this, even the static part of the heap gets disposed of. So, classes contain methods. Well, other stuff too. This is the biggest distinction in domain or scope, and getting the proper domain and scope. It's a pretty big important thing, because you don't get that right, and it just leads to confuzzlement. Otherwise, they share a lot of the same keywords. All right, so this scope keywords, and I'm going to refer to from the package level. Okay, from the package level, there's public or default. Okay, public means that when you call up this package, boom, this is what is meant for the package to be seen and used. Default, it's in the package, right? Okay, but it's not going to be listed for you to be using it. Now, all these public classes and enumerations and stuff will be referring to these anonymous classes, or they can. It's just that once it's packaged up, you just don't see the defaults. Okay, so public, visible, usable, anywhere, anytime. This is the reason for classes and reusing stuff. Protected. Okay, this is okay. We're no longer. I'll package level check. All right, package level. So default, a local variable. All right, not quite public. Visible and usable in this package, however, or in this class, or whatnot. It's just you forgot to. Well, it's not visible once the package is built. That's it. All the stuff inside of the package can use it, but once the package is built, that's it. Protected. Okay. Visible and usable for classes that extend or implement the class. I'll go over this in inheritance. Private. Only visible and usable for this class only. And again, inheritance. So these two specify what the kiddies can see and use versus everybody. And private is for not even the kiddies can use it. So, go figure. Okay. Scope keywords. There we go. So, at this time, I'm going to work with public and default. Code static stack and heap. Yes, we have our memory model. I put that into an appendix somewhere. And I'll just jump through this right quick. Of course, the entire package. You build it, and of course, it's executable and stuff. But it's put somewhere once, hard drive, and then you activate it, and the Java runtime environment takes that whole package and parses through it and pulls out, finds good old main, and then is like, okay, now what all do I need? Ah, yes, this, boom, loads it up in memory, bam. So, classes marked static. All right, they get methods and method signatures, and classes marked static. They get put into the static part first. Okay, gets constructed first. Meant for stuff that only needs one copy, and it needs to happen first. Okay, the stack. Of course, the stack gets started with main, and then it gets ready to start doing the whole program. So stack is the current instructions for current set of instructions and data unfolded for putting into code. Okay, last and first out frames. Yeah, I covered that. And the heap, and of course the heap contains a static section of the heap, and of course the heap itself, which is the dynamic bits for garbage collection when done. And so everything goes into the heap, but then it works on the static part of the heap first, and then fires up the stack to start running the program. So as far as classes go, usually we can think of classes going in the heap, or the dynamic part of the heap, because we make instance of the class, goes into the heap. And then, of course, the reference value gets put into the stack with the current method calling it. All right, yes, and we're still on for those people who are just translating into Java. 7 types of class variables. Yes, during my last run through this section, I got to see where it really trumps all over methods and a lot of other stuff, but it's all one big thing. So I'll cover the method specific stuff more in detail on the method section coming up next. So there's still 2 official types of 4 types of variables. Your primitive primitive values, and then your reference type values, and then of course those other 2, the wildcard and the raw. This has to do with extending in scope. Okay, so type 1, the class variable. All right, this is a static variable, okay, or a method signature. Okay, it doesn't really matter what method it is, or method signature. A copy of the method signature goes into the heap. It's kind of like a reference value of where the method can be found at. And this is accessed by the name of the class. So class name dot the variable, and it's disposed when the program exits. Okay, so definitely the class variable of static type. Okay, and the instance variable. This is an instance variable, and this is a non-static variable. Okay, it's initialized with the keyword new. So new is very important for working with instances. Accessed by the instance name that you assign it at that time of the class, dot the variable, and it's disposed along with the instance class. So the moment you set it to null, then boom, it's disposed of, ready for garbage collection. All right, the array components. Yes, this gets honorable mention. It's listed because it is a reference type of primitive used to work with an indexer, or good old array 0 plus 1 plus 2 plus 2. It's really of types 1 and 2, class variable or instance variable. But because the array is meant to be a whole list of data values of the same type. So 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6, and they're all the same size, so that you can run through them pretty quick. This is honorable mention due to its nature. So hey, yeah, an array. It can be a bunch of primitives, it can be a bunch of reference values, but because it is a sequence, it has its own address, and so it's worked with like an address, plus 1, plus 2, plus 3. The method parameter. Okay. Yes, this would be in the method signature. You'll have like the data values that you're wanting to pass in. And so a method parameter is one of these data values that you're passing into a method to get it fired up. So variables declared in a method signature, and they are disposed when the method completes. So once the method goes out of the stack, boom, those variables are disposed of. Next up, the constructor parameter. Okay, yes, a constructor is a special type of method which is meant to initialize values for a class. So hey, yeah, you start up a class, you can start up the methods. You have a method that can initialize those values to whatever you want. You can even get some feedback during that time and to decide what values to initialize. But anyway, the variable declared in a method signature for constructing and initializing a class instance. So say you want like a point on the screen, right? And you need a class to hold that point on the screen. Well, of course you can fire up the class, and one of the constructors you can create will accept, the x and y value, and boom, when the class is created, because it was specified with the initial x and y value, boom, there it is. It's set. It's ready to rock and roll with it. And of course, any values that you pass through through the constructor, they're disposed when the constructor method exits. Presumably because you set the initial class values to those values that you sent into the constructor. So, constructor parameter, like a method parameter, it's just gets honorable mention because constructors, they're a special type of method. Number 6, the exception parameter. Again, it's like construction parameter and method parameter. Of course, exceptions for error handling, so I'll cover that more in error handling. But this is the variable containing the current exception for a try-catch error handling block. So, and it's disposed when that exception catching method exits. And finally, number 7, the local variable. Yes, we've actually been using local variables all along. It's a variable. It's declared as default. In other words, there's no public, no private, or whatever. I say local variable because this is inside of a method. And when you declare something inside of a method without the public, protected, private, well, it's just inside of a method. You don't need to do the whole public, protected, private. Yeah, once the method exits, it disposes of it because it gets popped onto the stack with the rest of the stuff. It must be initialized before it can be used. That's one biggie. Because local variables aren't initialized, class variables are initialized, even if only to zeros and nulls and such. But local variables, you got to initialize it before you can use it. It's disposed of immediately upon exiting the current block of code, off of that stack. Now, big note, watch out when declaring and initializing a local variable inside of a switch statement. So if you remember from flow control, switch statements, they're meant to, skip chunks of code. And if you don't initialize a local variable, because you can declare a variable anywhere you want in code, it's just you do that inside of a switch statement and it gets skipped, and then you try to use it later. Ooh, that's a big watch out. So yeah, it could be skipped and lead to serious problems. Finally, keywords final, abstract, and extends. More in detail, class inheritance. Okay, and keywords, serializable, transient. More in detail on serialization or letting programs talk to each other. And keyword implements. More in detail on interfaces. And of course, interfaces have to do with methods and lining those out. Keyword volatile. More in detail on threads. And there we go. All right, this is I use JMonkey Engine. I use Java. I'm Charles Anderson, indie game developer. Project is Idiog. I've got an email. I've got a Twitter. All right, now let's go start playing with some of this stuff. All of those who are just needing the quick translation, there you go. And let's go back. Oh, Mountain Dew. Yes. All right, so let's go fire up, start having some fun, shall we? Oh, right. Yep, that. Okay. Good old JMonkey Engine. All right, so let's just start by making a class, shall we? I can make a class here. It can't be public. It'd have to be anonymous. I guess I could. I'll just add another one to the package. New class. Let's call it a sample class. Why not? It's inside my project. Yep, it's in my source packages. Yes, it's in with my beginner Java package, so all that's good, groovy, great. Alright, so now I've got a new class, and it's public. Alright, it's not executable like beginner Java is because I don't have my main, but I can make stuff inside here that can be used by my program. So, sample class, let's just do some quick class variables. Let's see, public, because I want it to be used. Let's say int. My int. Why not? Oh, and one thing you'll notice, I'm capitalizing my int this time. Oh, and yeah, I could go ahead. Yeah, I'll go ahead and initialize it. Just give it 5. Okay, 5. Yeah. All right, and let's go with another one. Public string. Why not? Was that lowercase? My string. Something cool. Why not? Was it public? Oh, and there. Alright, public string, my string, something cool. We can also go ahead and give it a method. Okay, I'm really going to cover methods more in methods, but I'll go ahead and throw one out there. Why not? I don't need to return anything. I just need to show that it does something. Scope first. Public void. Now, on methods, it's usually good to start it off with lowercase. Write something. And, ooh, yes, I'll need a string. And string to use. You cannot catch me on originality ever. Okay, and we'll just do like a quick print line. So system print line. There we are. I was like, Oh yeah. Ooh. String to use. All right, there we go. Okay, so there we go. It calls that. Yeah. Okay, so I've got a class here, and I've got it public. Yeah, I don't need to do any anonymous stuff yet. I mean, I could, but it's good to think of the stuff that you're wanting to reuse first. All right, let's head back over to beginner Java. All right, and you'll notice that I didn't declare anything static. I'll jump into that here in a moment, but let's see here. Here's the beginning of the program. There's the end of the program. So first, let's make a variable. Since nothing's static, it needs to be an instance, which is number 2 in this crazy list. Oh, wait, I have my methods open. Well, yes, save it. Okay. Yeah, classes. All right, so 7 types of class variables. All right, so class variable. Okay, static variable or method signature. Okay. So these are instance variables. I guess I could go ahead and create a class variable. Okay. Static. It's car. Why not? My car. And we'll set that equal to $. Oh, right. Gotta use single quotes. It's a character, not a string. Okay. Now, one of the cool things you'll notice, it's kind of like got this italics thing. That just means it's static. And let's see, public. Public. Static void. Right. Something. String to use. What? Oh, that's right. Thank you, JMonkey, for doing autocomplete. I just wasn't right there with you. And I'll just copy that. Okay, there we go. Public static. Oh, and public. I'll just make that public. Not doing inheritance yet. Okay, so, public static char my char. There we go. Okay, now let's show what each of these types are. Okay, so class variable. All right, static variable, or method signature. It doesn't really matter if the method's considered public or private. So this is a method signature, and this is a method signature. All right, and I'll go into more in detail on this with methods, but I'll just say at this time these are method signatures. All right, and here is a static class variable, and so when I refer to this, I'll use sample class dot my car or whatnot. And these are instanced variables. So when I make an instance, these become reality off of the blueprint. And so there we go. Those are those first 2 types. Array components, I don't have any arrays, but I guess I could. Method parameter, okay. Yeah, method parameter. I can just, yeah. This is a method parameter. Dang. Even over here in beginner Java. Yeah, that's a method parameter. In between them parentheses, all these data values here, those are method parameters. And of course, for the constructor, it's always the thing inside the little braces when doing a method or error handling thing. Okay, so let's go ahead and make an instance of good old sample class here. So let's see, sample class. My sample class. equals new sample class. Okay, so hey, I just instantiated it. Great. Now, my sample class is, you'll notice I started off with lowercase. This is a local variable right here. We're inside of a method, so there's really no public or private or protected inside of a method. All right, that's just for inside of class for all that scoping stuff. So, let's see. Oh, right, I got some values I can have fun with. Let's see here. First, let's let's use my sample classes. Oh, and of course, when you write it up, hey, there they are. They're public, they're visible, all that good stuff. And we also have write something, and we'll use that. And of course, we can just say, yo, what's up? And yeah, there we go. So that we're using an instanced method, so this will get popped onto the stack and then executed, and then it'll jump back to this frame in the stack. Also, the whole big difference between static and instantiated. Let's go ahead and write something. Oh, I need a string. Oh, you know what? String, temp string, why not? Equals. Don't need it yet, but let's see here. Temp string, let's set it equal to my simple class dot what all. Oh, I've got my string and my int. Yeah, I'll go my string. There we go. Oh, tip string. And oh, I guess we could go ahead and run this stuff. Show you working. See, yo, what's up? Something cool. That almost made sense. Yay. Now, static stuff, right? This class variable thing over here. It's accessed by class name dot the variable. So static variables or method signatures. All right. So check this out. If I try to do write static something, right? I've got to use this word right here, which is the class itself, because I'm referring to the static portion of it. So temp string equals sample class, because we're accessing something static, dot my car. What? Car. Right, to string. Assign value. Oh, that's it. Oh, incompatible types, yeah. Oi. I just nearly need to remember my toString stuff. That doesn't work. Sign values never used. How about this? cheating by using the concatenation. Ugh, I'm so evil. Well. Effectiveness is the key sometimes. And then my sample class. Oh, and you know what? We can also use this. Well, my sample class dot. Temp string. That works. And of course, when we run that now, we get the little $sign because I cheated by using this concatenation because I couldn't remember toString. Yeesh. Although it was what? String dot what? Value of course. And that goes inside of that. Okay, that's what I was trying to remember. Okay, string value of. Ugh, goodness gracious. And right. So we wrote that. Now we can also remember we have a static version of write something as well. Sample class dot write static something, and I can also write it that way. And of course, when we run it, boop, $sign. So the big thing between instantiated and static is with instantiated, you got to create an instance of it right here, and here's where it goes up into the heap. All right, and so the class is now in the heap. And even before this program begins, a static version of it, the blueprint, is put it into the static side. So italics for static stuff, just good old green and regular for instantiated stuff, and bada boom, bada bing, there you go. That's it in a nutshell for that. And these are method parameters right here. And of course, yeah, hey, these strings, yeah, from the command line, yeah, that's a method parameter too. So go figure. Let's see, sample class, class variable. This is considered to be a class, class variable. The whole method signature, all in its entirety. Also, this is also considered in its entirety. So as a class variable, and then there's the instantiated. Boom, boom. Yeah, these are created with instances and initialized. And come on. Array components. Yeah, okay, I'll do an array, I guess. Public, protected, private. Yep. That'll be more on kids. Classes and methods. Oh yeah. And wait, I think I already specified it, but just in case. All this stuff right here that I've created in here, all of this is local. Well, local variable. There's really no public, protected, or private inside of a method. So, all right, and of course, once the program's ended, all of it gets canned, including the static stuff, because, well, the program exits. All right, I think that pretty much does it. I hope I didn't go too long, and I went over the rough stuff. So, yeah, there's classes. Really cool way to organize stuff and methods and all that good stuff. All right. I will catch you guys later, and I'll have more cool stuff, because I'm going to go into methods more in detail on the next bit. Come on, pretty screen. There we go. I'm using JMonkey Engine and Java. My name's Charles Anderson. I'm an indie game developer. My project is Idiog. I've got an email. I've got a Twitter. And I hope it was fun for y'all, and peace out.